Very good morning. Welcome back to the session. This is Raghavendra, Information Technology, Institute of Aeronautical Engineering, Hyderabad. So today we are going to discuss about a very interesting topic, and even some questions may come in gates and UGC net or slate also. So this is types of errors and error correction techniques. So first of all, so during the transmission from one system to another system across the network. So first of all, we can simply say that there is a flow control, error control. So many times we heard the terminology. Okay, so initially, first of all, we must understand what is error, what are the various types of errors. Okay, then only we can understand what are the various detection methods and correction methods. These things we can concentrate. So today we'll start about what is an error, what are the types of errors. These things we can discuss. So we'll start the session. Types of errors. So there are three types of errors out there. So one is a single bit error, multiple bit error, and burst error. So these are the broad classification in the errors during the transmission across the internet, or we can say that networks. So first we'll see what is single bit error. So if you observe this figure, okay, so and we know that now we are discussing in data link layer. So data link layer, in the data link layer, data can be represented in the form of bits. So whenever, assume that this is a frame, okay, a frame consists of 8 bits, right? So here, when we are going to transfer this one frame, and at the receiver end, see, if you observe this one, all bits are as it is received by the receiver. When coming here, okay, so instead of 0, the receiver received 1. So that means, so 1 bit is errored bit across in the complete frame. So in the one particular frame, if only 1 bit will be errored, means then we can say that that is a 1 bit error. Right? Next one is multiple bit errors. So the name itself, we can understand multiple bit errors means. So in this multiple error bit, we are taking an example of one frame, and in that more than 1 bit will coming an error. See, if you observe in this sent frame and received frame here, so assume that it's 0, 1, 2, 3, 4, 5, 6, 7, right? 0 to 7. See here, and the fourth one, isn't it? You can say the third, no? 0, 1, 2, 3. And third and fifth one. So third one is 1, fifth one is 0. Instead, what will happen here? So it received by 0 and 1. Instead of 1, 0, the receiver received 0 and 1. So here, 2 bits are errored in one single frame. Okay, that's why it is this kind of errors we can call it as multiple bit errors. Whereas in the third important one is a burst error. So in this burst error, what will happen means the sender and receiver will transmit the frames. So during the transmission, so here more than one consecutive bits will be corrupted. That means the bits are going to be changed. Instead of 1, it may be 0, 0. Instead of 0, it may be 1. So like this, see here, from 1, 2, 3. See, these 3 bits are 0, 1, 1 actual data bits. But instead, what will happen? So 1, 0, 0 is received by the receiver like this. So that means consecutively more than 1 bit are going to be corrupted in the transmission. So such a kind of errors we can call it as an burst error. For example, we can say that length of the error. Okay, so when we are saying that, so what is the length of the error? Okay, so how to find the length of the error means, in the burst error, the starting bit and ending bit. Assume that this is a complete frame. In this particular frame, the starting error bit and ending error bit. See here, this is sent and this is receiver. Here what will happen? So instead of 0, it will be 1. Okay, again instead of 0, it will be 1. Again instead of 0, again it will be 1. So like this, the error bits are appeared in this receiver side. So here from the starting bit to ending bit. So I'm considering this is an burst error. Why? Because more than one consecutive bit are corrupted here. See, this is 1, this is 2 consecutively. Next immediately bit is going to be replaced with instead of 0 it will be replaced with 1, right? So similarly, so that's why now here 1, 2, 3, 4, 5. Okay, so that means the error length is 5 bits. Okay, the error length is 5 here. That means when the data is going to be transmitted, so the length of the particular error, until that means so only these 5 bits are going to be replaced from the sender. Like this, we are going to be transmit the data. Next is the error correction. So error correction we have a two kinds. So one is backward error correction, another one is forward error correction. Right? So what is backward error correction? What is forward error correction? So error correction generally, what is the meaning of error correction? So we know that so what is error? So what are the various types of errors? These things we have discussed now. So in this, so what is backward error correction? Forward error correction. We will see what is backward error correction. Generally correction in the sense, so when something is incorrect, so we can make it into correct. So these correction can be done in two ways. One is backward, another one is forward. So we will see one by one. In backward error correction, so when the receiver detects an error in the data received, it requests back the sender to transmit the data unit. That means, so whenever the receiver, after receiving the data frame, so the receiver is going to be identify that so particular frame is error. Okay, and that particular error is going to be need to correct it. Okay, so that message, error message is going to be sent back to the sender, right? So then only the sender is going to be retransmit the errored frame, right? So that is the backward correction. And forward error correction, when the receiver detects the some error in the data received, right? See please, here receiver is going to detecting the error. Okay, detect some error in the data received from the sender and it execute error correcting code. Okay, then what will happen? The receiver is going to be uh, executing the error correcting code. Okay, we will see what is error correcting code. Okay, which helps it to auto recover and to correct some kinds of errors. That means, so if it is a, we have discussed so far a single bit error, multiple bit error, burst error, isn't it? So if it is like a single bit error or multiple bit error, so like this, a small type of errors, we can easily correct it with the help of executing this error correcting codes. If the burst error or very some sort of a burst error length will be a very big in size, then it is very difficult. But small size errors we can easily correct by using this error correcting codes. So in the first case, that is backward error correction, is simple and can only be efficiently used where transmitting is not expensive. That means, so we can execute this backward error correction also, and that only, and especially when we are implementing this backward error correction means, so whenever this error correction is not expensive, right? If error correction is not expensive, then we can go ahead for the backward error correction. For example, if you take the fiber optics is a medium for data transmission from source to destination, isn't it? So we have a so many different transmission mediums available. Assume that in our example we will consider fiber optics. Okay, but in the case of wireless transmission, transmitting may cost too much, isn't it? We know that the cost and maintenance is very high when we are going to execute this fiber optic cable, right? So in such a scenarios, the data transmission is expensive. So that in such a cases we cannot able to execute a backward error correction. if it is within a land like less expensive applications we are going to be implemented, obviously the medium is also the cheaper one we are going to be preferred generally, isn't it? So in such a cases we can prefer backward error correction, but when it is expensive, then the backward error correction is not suggestible. So in the later case, forward error correction can be used. That means, so when it is not expensive for data transmission, we can use it forward error correction. And to correct the error in the data frame, the receiver must know exactly which bit in the frame is corrected. That means, so whenever the receiver is telling that, so I received so and so data frame in this, so some single bit error or multiple bit error or burst error is occurred. So how can the receiver is tell means, so whenever the receiver knows exactly that particular data frame is getting an error, then only the receiver can send an error message to the sender, isn't it? So to locate that bit error, redundant bits are used as a parity bits for an error detection, right? That means, so how the receiver will identify in one particular data frame is errored data frame or not. That means, so this can be possible with the redundant bits are going to be used for data transmission. That means, so actual data will be presented here, right? Apart from this actual data, so the sender is going to add some additional bits. We can say that redundant bits are going to be added to the data frame. So based on the redundant bits, so the receiver can identify whether the data frame is received correct data frame or errored data frame, right? For example, so we take a ASCII word of 7-bit data. So 7-bit is nothing but, so 0 to 7, right? Then there could be a 8 kind of information we need. The first 7-bit tell us which bit is error, and the one more bit to tell that there is no error, right? That means here out of 8, from 0 to 7, no? Total it will be 8, right? Here, so the first 7 bits, okay, so 1 0 to 6. So first 7 bits are going to be tells the data, actual data, okay, and the next bit are going to be tells that, so this is a redundant bit, okay. Based on this, so it will be identifies that the receiver identifies that whether the data frame is correct or not. So if it which bit is error, okay, so these things can be identified whether the error data frame is error or there is no error. So this can be identified by the receiver based on the this redundant bit, right? So today we are going to clearly discuss about what is error, what is different types of error, and how to identify these errors. So these things we are discussed. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.